Alright, this is lesson 36, reducing rational expressions. For the sake of time, we're not going to find excluded values. That's part of the lesson. We're going to do that on the next lesson. So, rational expressions have to do, whenever I see the word rational, it means, in math, rational means it's a fraction. So, it's like we're reducing fractions, okay? So, remember back in the day when you had like a problem like this, 7/21, your teacher would say, oh, what goes into both these? You could be like, oh, you could just write 1/3. Okay? Do you all agree? It's 1/3? Yeah, but why does that work? Most teachers didn't teach you why this works. So the reason why this works is you're supposed to use factors back in the day. So you were supposed to really think about what common factors in both 7 and 21. So they always skipped a step by making you cross it out and write 1/3, but they're skipping a step that's in there. So this is what they mean when we factor or simplify. A common factor of 7 and 21 is like on the numerator I could factor out a 7, right? 7 times what is 7? 1, right? And then on 21, 7 times what is 21? 3, right? So the numerator and denominators really have a common factor of 7, and then we cross out the 7s, and all we're left with is 1/3, right? Does that make sense? Okay, so that's the idea, but today we're not going to do simple fractions. We're going to use this concept and apply it to the stuff we've been doing, okay? So if you're on the video, these are the steps. You should pause them, and I'm going to move on here. Okay, big idea. The big idea is we need to reduce or take a big complex fraction and break it down to simple terms. And then, like I said, undefined and factor. We're going to talk about that on Monday, but factoring you already know. So here we go. Number 1. Okay, and number 1, we got 9a over 6a squared. So in both the numerator and denominator, I could recognize a common factor of 3, and then the a's I could simplify too. So I know that 9a is just like saying 3 times a, and that the denominator also has a common factor of 3, which is 3 times 2 times a. Now I'm noticing that my 2 3's here can have that they could cancel out because they're both a common factor, so I'm going to cross those out. And then I'm also noticing I have a pair of a's here that are both in my numerator and the denominator, so I can cross those out. And all I'm left with in my numerator is 3 over 2a. Okay? There's one more step we didn't talk about, but we'll talk about on Monday, but for today, this is all we're doing today. So that's number 1. Any questions on number 1? Okay, number 2, we got r squared minus 2r minus 3 all over r squared plus 5r plus 4. So you can't really cancel stuff out. You can't just be like cross the r squared with r squared, because this whole numerator and whole denominator has its own parentheses. Okay, so you'd have to cancel the whole set of parentheses for it to work out. So we're going to have to use the concepts we use. The numerator looks like a quadratic equation, so we have to think, is there a GCF? No. Can we do x box in the numerator? Yes. So we're going to start doing x box here in the numerator. Okay, and we're just going to do what we already know. We're just plugging the numbers in and finding factors, right? And when we do that, the numerator gets factored out to be r minus 3 times r minus 1, right? You agree? Denominator now, we can still do x box. We're going to have to factor that out too, and then we figure out it's going to be r plus 4 times r plus 1. Okay? Now you could clearly see what value is in both the numerator and the denominator. R plus 1, right? So those cancel out. So all I'm left with in the numerator is r minus 3 and r plus 4. Okay? What happened to my parentheses that were there? Do I need to include the parentheses in my answer? No, because we assume the whole numerator has its own set of parentheses, and so does the whole denominator, so we leave it alone. Therefore, since we assume it, we cannot cancel these r's. Do y'all got that? It's all kind of a package. Alright, so you go cancel out packages. Okay, that's how you do numbers 1 and 2. Questions on 1 or 2? Alright, so let's have you talk to your neighbor. Let's have 1 cell 2 is about number 1, 2 cell 1 is about number 2. Ready, set, and go. Here we go. Let's do a couple of these together. Let's jump to number 4. So skip number 3, please. Let's do this one together. What do you notice about number 4? What's a common factor you could see in both the numerator and denominator? 2 and what else? Okay, right, so the numerator, what can I factor out of the numerator? 2k, right? 2k times what is 4k squared? 2k, good. 2k times what is equal to negative 6k? What? Negative 3, good. The denominator, what's a factor I could take out of the denominator that's common in the numerator?
2.
2 and k, right? 2k times what is 8k squared? Good, okay. What can I cancel out in the numerator and denominator now? 2k, good. So all we got left is 2k minus 3 and over 4k. Why can't I cancel out 2k and 4? Because it's in a parentheses. Good. Did y'all hear that? We assume that there are parentheses, so we do not cancel those out. Good. Good? Makes sense? Okay. I say that because a lot of kids, they'll get to this point and they'll try to cancel out 2k and 4k and they'll say, oh, there's 2k here, and then it's like a big mess after. That's wrong, okay? We just leave it alone. You have to assume there's parentheses here that we don't include them because we assume that they're there. Okay, continue. Let's just jump straight to number 6. Okay, last problem, 6. Work this one out by yourself. I'll give you about a minute to do that. Ready, set, go. Alright, so this last one, the answer is m minus 1 over m plus 4. So, as for today's lesson, this is all we're working on, so we don't need to worry about excluded values. We'll talk about that on Monday, but just this is the first part. For the sake of time, this is all we're doing. Have a good weekend. We'll see you on Monday.